Okay. Chi-square, there are three types of chi-square, but in the exam you will get the big question based on, not homogeneous, sorry, goodness of fit. The homogeneous and the independence, the question would be just to identify. So I give you an example of goodness of fit. They tell you you have a randomly selected sample of 140 criminals. They want to see if it's equally likely that the number of crimes that they commit per day is the same or is it different. So in order to do this question, so they tell you they think it's equally likely. We want to see if this is true. Now to do this, first of all, a list day, so you have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And they give you the observed value. So they observed that 17 of those 140 crimes were done on Monday, 21 on Tuesday, 22 on Wednesday, 18 of them on Thursday, 23 on Friday, 24 on Saturday, and 15 on Sunday. Now, the percentage, since they say equally likely, there are 7 days, so this would be 1 out of 7, or all of them. Sometimes they could ask you the question and provide the Minitab. This would be provided in Minitab. And they give you different percentages. They tell you 20%, 10%, 5, 15, 6, whatever. They give you different percentages. But since they mention equally likely, then it's 17, 17 for all of them. The expected value in this case would be whatever the percentage is times the sample. So the sample is 140. So you go 1 out of 7 times 140, 20. So it would be 20, 20, 20, 20, 20, 20, 20. Now, there'd be more to, well, if the percentages were different, so you take whatever the 20%, 5, 6, whatever, you take whatever the percentage is times the n, which is 140, so you would have different expected. Here happens to be the same expected. So there'll be more to the table, we'll come back to that. And the Minitab, if they provide Minitab, and that's similar to the last assignment you guys did, you have a line called Pearson. You would have a chi-square value. You would have a degree of freedom. So maybe the degree of freedom would be first, and the chi-square, and then a p-value. Now, the degree of freedom for a goodness of fit would be number of groups minus 1, so you have 1, 2, 3, 7 minus 1, 6. Chi and the p-value will calculate, but again, I think there will be two lines provided, Pearson and the likelihood. You always go with the Pearson. We always care about the Pearson only. The idea of goodness of fit, they tell you that it's equally likely. So they expect in a sample, like if they do a study on a sample of 140, they expect 20 crimes to be Monday. They expect 20 crimes to be on Tuesday, 20 on Wednesday. This is what they expect. But this is what they observed. So when they took this 140, they found that 17 of them were actually done Monday, 21 on Tuesday. So it was a bit different than what they expected. This is what they expected, this is what they observed. Are the differences negligible? Are the differences too small so you can just forget about it? Or the differences are big and show something? Now, you would state the hypothesis first. Now, the way you do a hypothesis for goodness of fit, H0, you start with the name of the category. In this case, number of crimes. Is the same across the 7 days for all criminals in the population. HA would be the same, but instead of same, not the same. This is how you would state the hypothesis for goodness of fit. Now, let's calculate the chi-square and the p-value. I think that in the exam, most likely they will be provided like the last assignment. You need something called chi first. And chi is observed minus expected squared over expected. So you take the difference between these two in brackets, you square and you divide by the expected. So the difference, bracket 17 minus 20, you square it and divide by 20. This one is 4, 5. You do the second one, difference squared over 20, and that's 0.5. Difference squared over 20, 0.20. Difference squared over 20, 2.0. Difference squared over 20, 4.5. Difference squared over 20, 0.8, and finally the difference squared 125. After you do this, you add them all up, and that gives you your chi number. So 4.5 plus 0.5 plus 0.2 plus 0.2 plus 0.45, 0.8, and 125. Your chi number would be 3.4. So your chi-square is 3.4. P-value most likely will be provided in Minitab like they did in the assignment. But you can go to Google and just say chi-square table. So, in the chi-square table, your degree freedom we determined is 6. So you go to the 6. Where do you see this number? I've just randomly selected a chi table. So degree freedom 6. I look for this number 3, 4. the idea of DTT. It's between these two numbers. I know that p-value somewhere between 50% and 75. So in the Minitab, we'll tell you a number somewhere between. So say, it will tell you your p-value, say 60%. It will be provided. Now you're ready to make a conclusion. I'll do it both ways, based on strength and significance, and I'll use, for the significance, I'll use 5%. Actually, I think they use 1%, doesn't it? Okay, no talk about assumptions, so we say, if assumptions hold, and if you do with p-value, if your p-value is, say, 60%, that's way more than 10%. P-value 60 is more than 10%, so you have large p-value, weak, very weak evidence for HA. So you say we have very weak evidence for HA. But instead of HA, you say what HA is. We have weak evidence that the number of crimes is not the same across the 7 days, or that the number of crimes is not the same for across the 7 days for all criminals in the population. So we can't prove this. So that means that this one is correct, they're the same. So the observed and the expected the same, so what they expected is true. It fits with the actual observed numbers. If you base it on significance, you start with the same thing. If assumptions hold, but p-value is more than alpha. So you have insignificant results. Don't reject, cannot conclude HA. So we have at 5% level of significance, we have insignificant results, we cannot conclude HA, but instead of HA, you see this. We cannot conclude that the number of crimes, the same thing we did for the previous one. So basically, if your p-value less than alpha, then you have significant results. If it's more than alpha, you have insignificant results. Okay. One thing that they could also ask you to do is to discuss the assumptions for this chapter. And the assumptions for this chapter, for the Chi in general, are a little bit different. The first assumption is counted data. You have to have a category, and we do have a category. The category is the number of crimes is the category, and under that we have counts of crimes. So the observed value, if you remember, the 17, the 23, the 21, all of these are counts, number of crimes. It could be number of people, number of crimes, but it's something that you're counting. So it's not like 25 years or 26 inches. No, it's something that we count under a certain category. So the category in this case is the number of crimes, and under the category you have counts of crimes. Assumptions number 2 is the independence, and that's, so here condition met, of course. Here's also condition met, because if you read the question you have randomly selected 140 criminals. So the sample of criminals was selected randomly. So we're good. So the groups are independent of each other. The last assumption is sample size assumption, or also called expected frequency assumption. In order for this to be satisfied, the expected value, all of them must exceed the number 5. And they're all 20. So you say all expected values are greater than 5, since the minimum expected value is 20. So again, condition met. Okay, so this is all you need to know about the goodness of fit. You can review, there is one question, goodness of fit, in your assignment. The other one was, I believe, homogeneous. You will get questions where it's a chi-square, but it's either homogeneous or independent. Now, how do you determine whether it's homogeneous or independent? The difference between the homogeneous and the independent is whether you have one sample and 2 categorical variables. So one population with 2 categorical variables. If that's the case, then you would have independent type. If you have one categorical variable and two or more populations, then this would be the homogeneous. Like an example for the first one, they would tell you something like you have a sample of 200 people, and we ask them two questions. The two questions is identify your gender, and the other question was what's your preference of best school in Nova Scotia? But since there is only one sample selected and two different things that we're testing, one population, two categorical variables, that's independent. A homogeneous, you would select multiple groups, two or three. Something like you have samples selected, 100 from St. Mary's, 120 from Dal, and 80 from the Mount. So you have multiple samples, and you ask them one question. Do you like living in Halifax? So when you have multiple samples and you ask one question, that would be an example of homogeneous. I sent you two different questions to identify to see if they're homogeneous or not, homogeneous or independent. So we go to the first question. The public opinion surveyed a simple random sample of 1,000. So you have one sample of 1,000, and they're classified by gender and voting. So you have one sample and two classification or two categorical, so right away that's independent. If you read the second one, suppose you're interested in knowing whether the distribution of income classes, low, middle, high, are the same for 200 males, 250 females. So you have two samples given. So you have two or more populations, and the category is called the class or income class. So the category income class, but more than one sample. So if they specify multiple samples, homogeneous. One sample with two different categorical, it would be independent. If you have questions before the exam, let me know. Again, if you want the links for the videos I did for the paired sample and the two independent, let me know as well. But review this and the assignments and you should be okay. Good luck.